Have you ever just looked up, seen one of those massive airliners flying overhead and thought, how? I mean, how does something so complex, so powerful, even start to exist? Well, today we're going to dive into that because we're exploring the incredible journey of aircraft design, from just a simple idea to a machine that literally conquers the sky.
It is a huge question, right? Taking a concept that's just in your head and turning it into a real flying object that weighs hundreds of tons. I mean, that's one of the greatest engineering challenges out there. So where does it all begin? Well, it starts with understanding what design even is.
I really like this definition from Anderson. Before a single piece of metal is ever cut, design is an intellectual engineering process. It's an active creation that happens first in the mind and on paper, or, on a computer screen these days. It's basically a structured dream. So, to really get this journey, we're going to follow a pretty clear path. We'll kick things off with the spark, what design truly is. Then, we'll look at the rules of the road that govern the process, walk through the 3 big trials of its creation, check out a major shift in modern thinking, and finally, we'll look ahead to the next horizon. Okay, so let's start with that first spark, because to really appreciate the whole process, we kind of need to be on the same page about what design actually means. And you'll see, it's not just one thing, it's a concept built on a few key ideas. See, design isn't just one thing. It's about the geometry, the physical shape of what you're building, like Raymer says. It's about having a crystal clear purpose, which McGovern points out. It absolutely requires a systematic plan. And as we heard from Anderson, it's a deeply intellectual process. You put all of that together, and that's when you get the blueprint for innovation.
All right, so now that we know what design is, what are the fundamental rules that every single aircraft design team has to play by? These are like the non-negotiables that shape the entire journey.
So every single design starts by answering a need. But, and this is crucial, there's never just one perfect solution. It's always a series of really smart compromises. The whole thing has to be systematic, it's deeply interdisciplinary, and it's a massive exercise in teamwork. But the principle I really want to zoom in on is that it's iterative.
And what's so cool about this slide is it shows you exactly what that means. The process isn't a straight line from point A to point B. It's a loop. You move forward, you test an idea, you find a problem, and you have to go back a step or two. This cycle of refining and retesting is constant, and honestly, it's where the real magic happens.
And this just perfectly illustrates why teamwork is so vital. You've got specialists in aerodynamics, propulsion, structures, flight controls. All these different experts have to work together seamlessly. An aircraft is a system of systems, and there's just no way a single person can be an expert in the whole shebang. So let's move into the core process and see how this all builds up. You can really think about the creation of an aircraft as passing through 3 great trials, or phases. And each one gets more detailed, more expensive, and a whole lot more real. It all starts with conceptual design. That's the big picture, what-if stage. Then it moves into preliminary design, which is where the overall shape gets locked in. And finally, it all comes together in detailed design, where every last nut and bolt is accounted for. The conceptual phase is really the creative, fuzzy beginning. It's where you ask the big questions. Will this even work? What should it look like? What's the general size and weight going to be? It's all very high level, driven by the absolute fundamentals of flight. Aerodynamics and propulsion. Okay, once the concept seems like it has legs, we enter preliminary design, and this is where the dream meets reality. Big sweeping changes are pretty much off the table. Now you're seeing tons of analysis, wind tunnel tests, computer simulations. The most important part, though, is that this phase ends with a huge decision. Do we commit the millions or even billions of dollars to keep going? It's basically the point of no return. If the project gets that go, it enters detailed design. And this is the painstaking final act. I mean, engineers make super precise decisions for every single component that has to be manufactured. They build these physical test rigs called Iron Birds, which are full-scale mock-ups of the plane systems on the ground, and they run thousands of hours in flight simulators to make sure everything works perfectly before the actual aircraft is even built.
But the way we navigate these 3 phases today, it's gone through a massive change. There's been a huge paradigm shift in the entire philosophy of aircraft design, moving the main focus from one single goal to a totally different one.
To really get this shift, you have to understand this one graph. It shows the fundamental dilemma of all design. See that design freedom curve? It's at its highest right at the beginning, in that conceptual phase. That's when you can make big, sweeping changes for cheap. But now look at the knowledge curve. Your actual knowledge about the design is at its absolute lowest point, so you're making the most important decisions with the least amount of information. That's the problem.
So, historically, the solution was just a design for pure performance. Go faster, fly higher, push the envelope. Cost was just an output of that process, something you figured out at the end. But the new way completely flips that on its head. The goal now is to design for affordability. You're designing for the entire lifecycle cost, from manufacturing all the way to maintenance. Cost isn't an output anymore, it's a critical input right from day one.
And this visual just perfectly illustrates the modern solution. The whole goal is to use advanced computer modeling, simulations, and all these interdisciplinary teams to basically drag that knowledge curve to the left. The idea is you gain more knowledge way faster and much earlier in the process when your design freedom is still high and you haven't locked in all those costs. It's all about making smarter decisions when they really matter the most.
So where does all this lead? This modern approach of front-loading knowledge, well, it's pointing toward a truly revolutionary future for how we design and build aircraft.
The long-term goal is, well, it's nothing short of creating a complete virtual engineering environment. Just imagine a digital world where you can design, build, test, and even fly a brand new aircraft with incredible accuracy, all inside a simulation, before you even think about building anything in the real world.
And that really leaves us with a final thought to chew on. What becomes possible when you can design, build, and fly an entire aircraft in a virtual world before a single piece of metal is ever cut? What new frontiers of efficiency, performance, and innovation open up then? It seems the sky is no longer the limit.